Imagine a machine so powerful, so precise, that it could reshape an entire industry. That machine exists, and it's called Russia's GTD-110M engine. But this isn't just another piece of industrial equipment. Some engineers and experts are calling it one of humanity's greatest engineering achievements. Why does it matter so much? Because this engine represents more than power. It's a symbol of survival, innovation, and national pride. It was born in a moment of crisis, designed to replace decades of reliance on foreign technology. The questions are simple but profound. Why was this engine created? How could it possibly match or even surpass the giants of Western engineering like Siemens or GE? The stakes couldn't be higher. Energy isn't just about electricity, it's about independence, security, and control. One engine, one breakthrough, could redefine Russia's technological landscape and possibly challenge the global status quo. Today, we're going to dive into the story behind the GTD-110M, how it came to be, why it's special, and the impact it's already having. This is a story of ingenuity under pressure, of engineers racing against time, and a nation striving to reclaim its place in the world of high-tech power. To understand why the GTD-110M matters, we need to rewind a bit. After the collapse of the Soviet Union, Russia faced a harsh reality. Its energy infrastructure was aging, and the country no longer had the industrial base to produce the advanced turbines it needed. For decades, Russia relied on Western companies like Siemens and GE to supply and maintain the turbines that powered its cities and industries. At first, this seemed smart. The turbines were efficient, reliable, and cutting-edge, but there was a hidden cost. Every turbine purchased meant spending millions of dollars abroad, and any repairs or maintenance required foreign experts. It was like borrowing tools from a neighbor every time something broke in your house. Expensive, inconvenient, and risky. Then came 2022. With sanctions imposed, Western companies pulled out, cutting off access to new turbines and leaving older ones without proper maintenance. Russia faced an immediate crisis. Power plants couldn't operate at full capacity, and the energy grid teetered on the edge of failure. For the first time, the country saw just how vulnerable it had become. Necessity became urgent. Without a plan to produce its own turbines, Russia risked not just economic disruption, but a full-scale energy crisis. This pressure set the stage for a bold, high-stakes response, creating an engine that could do what no imported turbine could: work flawlessly under Russian conditions, built entirely at home. When the Western turbines stopped coming, Russia faced a choice: scramble for temporary fixes or take a daring leap into self-reliance. Enter Sergei Koff and his team at Ross Corporation, a group of engineers determined to build something entirely Russian, something that could not only replace foreign technology, but outperform it. They began by gathering some of the brightest minds across the country, pooling knowledge, skills, and resources from multiple industries. Companies like Power Machines joined forces, creating a network of expertise that spanned Russia's industrial landscape. The goal was clear: build a high-powered, efficient turbine entirely in-house, capable of sustaining the country's energy needs without foreign dependency. Designing an engine of this scale from scratch was no small feat. Every component had to meet exacting standards, from the materials that could withstand extreme temperatures to the precision engineering that ensures every moving part operates flawlessly. Mistakes weren't just setbacks. They could destroy months of work and millions in investment. But this wasn't just about solving an energy problem. The engineers knew that mastering turbine technology at this level could have ripple effects beyond power generation. The innovations developed here could influence aviation, industrial machinery, and future high-tech industries. In other words, the GTD-110M was the start of a larger revolution, a step toward technological independence on multiple fronts. Creating the GTD-110M was far from a smooth ride. From the very beginning, the Ross Corporation team faced challenges that tested their skills, patience, and, honestly, their ingenuity. Early prototypes exploded during testing, which was a stark reminder of just how unforgiving turbine technology can be. Every material had to withstand scorching heat and crushing pressure, and every component had to fit together with microscopic precision. One tiny flaw could compromise the entire system. But setbacks didn't stop the engineers. They became lessons. Every failure taught them something new about materials, aerodynamics, fuel efficiency, or thermal management. Piece by piece, test by test, the turbine began to take shape. They experimented with lighter and more compact designs, aiming to match or even surpass the efficiency of Western competitors, all while reducing installation and maintenance challenges. The process demanded relentless focus. Unlike mass-produced gadgets, this engine required an extraordinary combination of science, art, and intuition. It was a puzzle that took years to solve, and really, every small breakthrough was hard-won. By the time the turbine reached its final form, it wasn't just a functional machine, it was the result of an epic engineering journey, a testament to the skill, perseverance, and determination of everyone involved. The development journey didn't just build a turbine, it built confidence, a belief that Russia could innovate under pressure and turn necessity into opportunity. So, what exactly sets the GTD-110M apart from every other turbine on the market? The answer lies in its combination of power, efficiency, and innovation, all wrapped up in a machine entirely designed and built in Russia. First, power. This engine is a beast. It can generate enough electricity to supply an entire city or fuel large industrial complexes. That's not just impressive on paper. It's a tangible way to keep communities, businesses, and industries running smoothly. Second, efficiency. The GTD produces more energy while consuming less fuel, cutting costs and reducing waste. In an age when energy efficiency is critical, this makes a huge difference for both the economy and the environment. Third, design. Compared to its Western rivals, the GTD is lighter, more compact, and easier to transport and install. Imagine trying to move a giant appliance across a city. Now imagine doing it with a massive turbine. A smaller, smarter design makes that possible without sacrificing performance. Fourth, materials. The engineers developed components capable of withstanding extreme heat and pressure, ensuring reliability even in the harshest conditions. Fewer breakdowns mean less downtime, lower maintenance costs, and a longer operational life. Finally, independence. Every part, from the first blueprint to the final assembly, was made in Russia. This isn't just a point of pride. It's a game changer for energy security. No more reliance on foreign suppliers, no more vulnerabilities exposed by sanctions. The GTD isn't just a turbine. It's a symbol of technological independence and a potential stepping stone for innovations in aviation and other high-tech industries. It shows that Russia can not only compete, but also innovate on its own terms. The GTD-110M isn't just a marvel in theory. It's making a real, measurable difference across Russia. Take the Uteria power plant in the Kodart region, for example. Before the GTD, the plant's output was 454 megawatts. After installation, it jumped to 560 megawatts, enough to supply roughly 10% of the region's electricity needs. Homes, businesses, and factories all gained reliable power, and the local economy felt the immediate benefits. Reliability is another game changer. Southern Russia, like many developing regions, faces fluctuating energy demand. The GTD provides stability, ensuring fewer outages during peak periods. For businesses, this means uninterrupted production. For residents, it means lights on, heat running, and essential services functioning without disruption. Economically, the impact is massive. By producing turbines domestically, Russia keeps billions of dollars inside the country instead of sending them abroad to Western manufacturers. This fuels local industries, supports research and development, and creates skilled jobs for engineers, technicians, and factory workers. On a national and geopolitical level, the GTD strengthens energy independence. Russia no longer has to fear external suppliers pulling the plug. Controlling its own energy infrastructure gives the country strategic leverage and resilience in a world where energy is power, in every sense of the word. In short, the GTD-110M isn't just an engine powering cities. It's a catalyst for economic growth, technological advancement, and national security, showing how one innovation can ripple through an entire country. Even with the GTD-110M up and running, Russia's journey toward energy independence is far from complete. Manufacturing a turbine of this scale is one of the most complex engineering challenges imaginable. Scaling production to multiple units per year requires massive investments in factories, advanced machinery, and highly skilled labor. It's not just about building one turbine, it's about creating a sustainable system that can keep producing and maintaining these engines reliably. Competition is another hurdle. Western manufacturers like Siemens and GE have decades of experience and global supply chains backing them. Catching up isn't simply a matter of technology, it's about consistency, quality control, and mastering every stage of production at scale. Every turbine must meet rigorous reliability standards, ensuring it can operate continuously under extreme conditions for years without failure. Yet, the progress so far demonstrates that Russia can overcome adversity. Each turbine built, each technical challenge solved, adds to the country's knowledge base and industrial capability. If momentum continues, the GTD could pave the way for even more advanced turbines, as well as innovations in aviation, industrial machinery, and other high-tech sectors. In short, the GTD-110M is not just a finished product, it's the foundation of a long-term technological journey. The road ahead is tough, but the first steps have already shown what's possible when necessity, ingenuity, and determination intersect. The GTD-110M isn't just a technical achievement, it's a powerful symbol of Russia's resilience, independence, and evolving role on the global stage. When Western giants like Siemens and GE withdrew in 2022, it exposed the risks of relying on foreign technology. The GTD was Russia's answer, a declaration that the country could innovate, produce, and thrive on its own terms, even under immense pressure. Beyond politics, the engine teaches us a broader lesson about innovation under adversity. Necessity drove creativity, and determination turned obstacles into breakthroughs. The GTD shows that with focus, collaboration, and perseverance, even the most complex challenges can be overcome. This turbine also reflects a shift in global dynamics. Energy is no longer just about powering homes and factories. It's a strategic tool, an economic driver, and a measure of technological independence. By mastering its own energy technology, Russia strengthens its position in the global energy market and opens doors to future opportunities, including potential exports and advancements in aviation and high-tech industries. For viewers, the story of the GTD is both awe-inspiring and instructive. It's a reminder that engineering is not just about machines, but about vision, courage, and the ability to turn crisis into opportunity. If this story fascinated you, share it with others and keep an eye on Russia's next steps in energy and technology. The GTD-110M is only the beginning, and who knows what historic milestones are coming next.